Hello and welcome to this video on volume. This is part of our Functional Skills Maths Level 1 and 2 course. The learning outcome for this video is to calculate the volume of cubes, cuboids and cylinders. The definition of volume is that it's the quantity of three-dimensional space enclosed by a boundary. The linked learning goes back to our two-dimensional shapes, where when we calculated the area of a two-dimensional shape, we multiplied the two dimensions. For three-dimensional shapes, we always do something with the third dimension. So for a cube, we had the area of a square, and then you multiply it by the third dimension. For a cuboid, you had the area of a rectangle and you multiply it by the third dimension. For a cylinder, we know how to calculate the area of a circle and we multiply it by this third dimension. And finally, for a triangle, we know how to calculate the area of a triangle and again, you multiply it by the third dimension. For level 1, sometimes they will give you various shapes made up of centimetre cubes. So in this image here, we have a centimetre cube and there are 1, 2, 3, 4, 5, 6 cubes. So the volume of this particular cuboid would be 6 centimetres cubed. So notice how the three dimensions are annotated on our units, much like our area, the little 2, was on our units for those. So you could get questions on unit cubes at level 1, and all you really need to do is count the number of centimetre cubes. Give your answer, and don't forget the units are centimetres with a cube on the units. Here's one to practice at. So what is the volume of this object? So again, we're merely counting the number of cubes in the object. 1, 2, 3, 4, 5, 6. So the volume of this particular object is 6 centimetres and cube is telling us we're talking about volume. At level 1 and level 2, you'll also be expected to calculate the volume of a cube or a cuboid by multiplying the three dimensions together. So the base times the height times the depth. Now we've already done the base times the height to get the area of the shape facing us, so we're multiplying it by that third dimension to give us the depth. Whatever the units you're given becomes cubed to show that you've calculated the volume of that object. So here are two cuboids for you to calculate the volume for. Okay, so for the first one, our three dimensions are 4 centimetres times 10 centimetres times 15 centimetres. And that gives us 600. They're centimetres and it's cubed because we're talking about volume. The one on the right, slightly more complicated, and you'll need your calculator. Now write down exactly what's on your calculator first, and then if they ask you to round it, or you want to round it yourself, just write rounded to 5.9 meters cubed. Now, a lot of the volume questions that you get in the exam are volumes within volumes, much like your tiling exercise with areas. So you calculate the volume of the big object and you divide it by the volume of the small object. But You've got to remember to be in the same units for both before you start. Here's an example. Annette is moving home and uses a rented van for the job. The back of the van has the dimensions 1.8 meter by 3 meters by 2.4 meters. The boxes she is using are cubes with sides of 60 centimeters. What is the maximum number of boxes she can put in the van? So we need to decide before we start whether we're working in meters or centimeters. Whichever one we go for, we have to convert the other. So let's work in meters. So the volume of our back of our van is 1.8 times 2.4 times the third dimension, which is 3. So let's do that first. So the volume of our back of our van is 12.96 and the units are meters cubed. Now at the moment we have 60 centimeters. So knowing what we do about converting a small unit to a big unit, we divide centi by 100. So if we divide by 100, we get 0.6 of a meter for the dimensions of our cube. So remember the properties of a cube? All of the dimensions are the same. So each of the edges for our 3 dimensions is 0.6. That's why they only gave us one of the edges when they were defining the box itself. So let's work out the volume of our small box. It's 0.6 times 0.6 times 0.6. And that gives us 0.216, and that's also meters cubed because we've been working in meters now. So to work out how many small boxes fit inside the back of the van, we divide the volume of the back of the van by the volume of the small box, making sure they're in the same units. And that tells us that exactly 60 boxes fit into the back of the van. And that's a pretty typical question where they give you mixed units of meters and centimeters, and it's a small volume going inside a bigger volume. Now the volume for a triangular prism is exactly the same as a volume for a cuboid, but you need to remember to divide by 2. So remember when we had the area of a triangle. It was exactly the same as the area of a rectangle, but then we needed to divide it by 2. So we multiplied the base by the height and then divided it by 2. Well, it's absolutely no different for the volume of a triangular prism. You work out the area of the triangle that's facing you and you multiply it by that third dimension, which is depth. So just like our area of our triangle here, we're multiplying it by the third dimension. So it can look like the base times the height times the depth, all divided by 2. Here are 2 triangular prisms for you to have a go at. If it's easier, work out the area of the 2-dimensional shape and then multiply it by the third dimension. Let's have a go. So for our triangle that's facing us, we have 10 times 10, which is 100, and we divide it by 2 to give us 50 centimeters squared for the triangle that's facing us. That's the area of the triangle. All we need to do to calculate the volume, once we know the area of the triangle, is multiply it by the third dimension. And that gives us 1,250 centimeters cubed for the volume of this triangular prism. The same for the one on the right. You can work out the area of your triangle first and then multiply it by that third dimension. So the area of the triangle would be 16 times 12, which is 192. Divide that by 2, you get 96 meters squared as the area of this triangle that's facing you. Then all you need to do to calculate the volume is take the area of that triangle and multiply it by your third dimension. So you get 960 meters cubed as the volume of the triangular prism on the right. Now, closely associated with volume is something called surface area. Now, it's not in the curriculum specifically, but it does appear in the CGP Level 2 book. So we'll cover it just to make sure. When you have a cube or a cuboid, some of the sides are the same, like the front is the same as the back, the right hand side is the same as the left hand side, and the top has the same dimensions as the bottom. When you're working out surface area, you need to work out the area for each of the faces and add them together. So for this cuboid here, I've already given you the areas of the 3 faces. Now, because the front face is 13, the back face is also 13. Because the right hand side has an area of 9 centimeters squared, then so does the left hand side. Similarly, if the top of the shape has an area of 6 centimeters squared, so does the bottom. So when we add those together, you end up with 56 centimeters squared. And that is the area, the surface area of the 6 sides of the 3-dimensional shape. Have a go at the one on the right and see if you can work out the surface area for the cuboid on the right. The starting place is to work out the area of the 3 faces that you can see. So this one here, that's at the front, is 15 times 10, which is 150 centimeters squared. This side is 4 times 15, which is 60 centimeters squared. And the top is 10 by 4, which is 40 centimeters squared. Now, as before, if we know the area of the face at the front, then all we need to do is add the face at the back. If we know that the right hand side is 60, then we know that the left hand side is 60. And if the top of the shape is 40, then the bottom of the shape is also 40. And this gives us 500 centimeters squared as the surface area of the cuboid that we're looking at. Here's a functional skills type question on surface areas. Below are the dimensions of the walls of a room that need painting. If one tin of paint covers 10 meters squared, how many tins of paint will be needed to paint the 4 walls? So we need to work out the surface area of the 4 walls in order to work out how much paint we need. Okay, so to work out the surface area of this wall that's facing us, we multiply 2.4 by 3.2, and that gives us 7.68 meters squared. For this wall on the right hand side, the area is 1.8 times 2.4. That's 4.32 meters squared. Now, we don't have to work out the area of the top because it's not told us that it wants to calculate or paint the ceiling. So all we need are the 4 walls. So we know one of the walls is 7.68 at the front, therefore the back must be 7.68. We know the right hand wall is 4.32, so the left hand wall must be 4.32. So the total surface area for those 4 walls is 24 meters squared. So answer the question. 24 divided by 10 equals 2.4 tins. So we can't use 2 tins. We need to round up to 3 tins of paint. Now let's look at the volume of a cylinder. Now again, as with the two-dimensional shape, the circle, the area is pi r squared, and you need to commit that to memory. You need to memorize this formula. With our other three-dimensional shapes, the cylinder is no different. If you can calculate the area of the two-dimensional shape, which is the circle, then all you need to do for the volume is multiply it by the third dimension, the height. So this gives us the area of the circle times the third dimension, or pi r squared h as it's referred to in formula, where pi times the radius squared times the height gives you the volume of a cylinder. Here are two cylinders to have a go at calculating their volumes, remembering the formula. You have to remember the formula. So the start of the formula is pi r squared, because that's the area of the circle, times the height of our three-dimensional shape, our third dimension. So that gives us, when we do our substitution method, 3.14 is pi times the radius. Now they've given us the diameter of 8, so the radius is 4 centimeters. So it's 4 squared times the height here, which is 9 centimeters. And we can put this straight into our calculator. Okay, let's take a look at our cylinder on the right. So if you ever forget what the formula is for the volume of a cylinder, just remember the area is pi r squared for the circle, and you're multiplying it by the third dimension, which is the height. So we know that pi is 3.14. We know when they're together we multiply. Now the radius, they've given us a diameter of 6, so the radius is half that distance. So the radius is 3, don't forget to square it, times the height that they've given us here, which is 6. So put this into your calculator, 3.14 times 3 squared times 6. And that gives you the volume 169.56. This time it's meters, and because it's volume, it's cubed. Here's a functional skills type question on cylinders where we have a volume going into a volume. So Jenny fills some empty flower pots with compost. Each flower pot is in the shape of a cylinder that's 15 centimeters high and a radius of 6 centimeters. She has a 15-litre bag of compost where 1 litre fills 1,000 centimeters cubed. She fills up each flower pot completely. How many flower pots can she fill completely? You must show you're working out. So we have a difference in litres and centimetres that we'll need to resolve at some point. Because of the conversion, we have to do the conversion once we've worked out the volume of our cylinder in centimetres cubed. So the volume of our cylinder is pi r squared, which is the circle, times the height. So it's 3.14 times, now it's given us the radius this time, squared, times the height of our pot, which is 15 centimeters. Put this into your calculator and you get 1,695.6 centimeters cubed. Now, to work out the answer for our 15-litre bag of compost, let's convert our compost into centimeters cubed, like our answer here for our volume. So we know that we've got a strap line, centimeters cubed to litres. 1,000 of these is one of those. I haven't got one of those, I've got 15 litres. So my scale is 15. Multiply this by 15, we end up with 15,000 centimeters cubed of compost. So this is our big volume, this is our little volume. So divide your big volume by your little volume to work out how many pots we can fill. And that gives us 8.8464 as an answer on our calculator. So we need to round it to 8 pots that can be filled because you've got a little bit extra left over. Let's have a look at a classic question to do with volumes of cylinders. Heinz are designing a new family-sized tin for their soups. If the new tin has a radius of 2 inches, so a radius of 2 inches, and a height of 8 inches, what is the volume in centimeters cubed? And they're giving us a strap line here of 1 inch equals 2.54 centimeters. So we're going to have to change our inches to centimeters first before we calculate the volume in centimeters cubed, because this is the only conversion we've got. So the strap line says we've got inches and we've got centimeters, and 1 inch is 2.54 centimeters. We'll change the 2 inches first. So we haven't got 1 inch, we've got 2 inch, so we've multiplied by 2. Multiply the other side by 2 and we get 5.08 centimeters. Now the 2 inches is multiplied by 4 to give us 8 inches. Therefore, all I need to do is multiply the 5.08 centimeters by 4 and it will tell me what 8 inches is worth, which is 20.32 centimeters. So now I have my dimensions in centimeters. I can put them into the formula for volume. So the volume of a cylinder is pi r squared h, where pi is 3.14, the radius in centimeters is 5.08, and I need to square it, times the height of my tin in centimeters, which is 20.32. I can put this into my calculator in one go, and I get 1,646 point, and then it goes on a bit. It's 572,191, and that's exactly what my calculator is showing, and that's what I'll write down. Now, normally in a question like this, it will say rounded to 2 decimal places. So let's do that. Let's look at the second decimal place and check the next one along, and we stick. So to 2 decimal places, it's 1646.57, and that's centimeters cubed. Now, if you're asked for the volume of any other 3-dimensional shape, they have to give you the formula. The formula are pretty standard as well, where you calculate the area of your 2-dimensional shape and you multiply it by the 3rd dimension. You calculate the area of your 2-dimensional shape and you multiply it by your 3rd dimension. But then you need a factor to then divide by. So for example, if they wanted you to work out the volume of a pyramid, they have to give you this formula of height times length times width divided by 3. If they wanted you to calculate the volume of a cone, then they'd have to give you the formula pi r squared times the height divided by 3. So all it comes down to with the volume of other 3-dimensional shapes is understanding formula and how to substitute into the formula. Let's have a look at a question to practice that skill. Mabel fills a cone of slush puppy to the top. What is the volume of slush puppy that fills this cone? The volume of a cone is pi r squared h over 3. So we know pi is 3.14 times the radius we understand is 5, so we're going to square it, times the height of our cone, which is 15 centimeters. And then you have to divide the whole thing by 3. So you can put this in your calculator in one go, either by creating a fraction or doing BIDMAS. So we have 3.14 times 5 squared times 15 equals, and then divide it by 3. And we end up with 392.5 centimeters cubed. And that completes the learning outcome to calculate the volume of cubes, cuboids and cylinders. And don't forget, you'll be given formula for other three-dimensional shapes. The buzzwords for this lesson have been volume, where you have the area of your two-dimensional shape multiplied by your third dimension. That's the best way to remember the way to calculate volumes of the basic three-dimensional shapes, such as the cube, the cuboid, the triangular prism, and the cylinder. The surface area does what it says on the box. It's where you calculate the area of each of your faces. And you add them together. Please remember, for some volumes you have to remember the formula. So volume is equal to pi r squared times h. The best way to remember it is you already remember the area of a circle as pi r squared, and then just multiply it by that third dimension, the height. And that concludes this lesson on volumes of three-dimensional shapes. If you need any more worksheets or information, please don't hesitate to see your tutor. I hope you've enjoyed this video.